In this video, we have the parallel arrangement of two resistors. This is given as R, while the resistance of this is 5 ohms. Of course, this is the ammeter that measures the electric current. The source voltage here is 4 volts, and the current flowing through this arrangement is given as 2 amps. Okay, now in this question we expect to calculate the value of the unknown resistance R, as well as the current flowing through R. We expect to calculate the current that is flowing through this resistor R as well. So those are the two target variables we expect to calculate. And how to solve this problem? The first thing is you have to find the equivalent resistance of these two parallel resistors. Okay, of course they are in parallel. So now let's assume the equivalent resistance is going to be, let's call it R prime. Okay, R prime, which is equivalent resistance, will be equal to R parallel 5. Okay, so that will be equal to our product R times 5 over sum R plus 5. Okay, so the equivalent resistance of the parallel combination will be equal to R times 5 will give us 5R over R plus 5, or let's call it 5 plus R. Okay, now we'll apply our Ohm's law. Okay, so that's going to be V equals to I R prime. That's our Ohm's law. Ohm's law. Okay, so now let's plug in the values. Our V, the source voltage, is 4. Now current given in this setup, which is what? 2 amps. I will be equal to 2. Now what is our R prime? So I'm going to substitute this. That will give us 5R over what? 5 plus R. Okay, now by the time we distribute this, we're going to have 4 equals to 2 times 5R will give us 10R over 5 plus R. Now we're going to cross multiply. We assume this is 1. 10R times 1 will give us 10R. That will be equal to 4 multiplied by everything here will be 4 open bracket 5 plus R. Okay, so now what will that give us? 10R equals to, now we distribute this, we use 4 to multiply everything in the parentheses. 4 times 5 is 20 plus 4 times R, which is what? 4R. We collect like terms. That gives 10R minus 4R equals to 20. So 10R minus 4R will give us 6R. Okay, which will be equal to what? 20. Now what's our value of R? R will be equal to 20 divided by 6. So what's 20 divided by 6? 20 divided by 6 will give us that's 3.33 ohms. Okay, so that means our known resistance is 3.3 ohms. Okay, that's the answer to that. Now in the next question, we are supposed to calculate the current through the resistor, the R. Okay, now in order to solve that, notice that the voltage in this circuit, the source voltage is 4 volts, and this is an arrangement in parallel. So that means the voltage across these two parallel resistors, these two combination will be 4 volts. So we simply apply Ohm's law. Okay, you know, if we know that V is 4 volts and R is 3.3, so we can say if you apply Ohm's law, okay, V equals to IR. Okay, the source voltage is 4 equals to I, this time around will be current through that resistor, I sub R, which is what we use here, I sub R. Okay, now from there we multiply by the R calculated resistance value. There is what? 3.3. okay, so that means 4 is equals to 3.3 I sub R. That's the current to the resistor. Okay, now what is I sub R? I sub R will give us 4 divided by 3.3. Now what is 4 divided by 3.3? Okay, let's check what that will give us. 4 divided by 3.3, that will give us 1.21. Okay, so now we can see the current through that resistor is 1.21 amps, right? Now we have another method that we can apply to solve that. Okay, if I sketch out that arrangement again, all I need to do is just sketch out those two resistors. Okay, so one is the one we calculated, that's 3.3 ohms. Okay, while the other one is 5 ohms. 5 ohms. Okay, this is another way or another method of calculating that, and I'm going to checking the value of the source current. That's about 2 amps. So that means the current entering here, let's call it total current, okay, is 2 amps, right? Now I'm going to call this resistor 1, I'll call this resistor 2. Okay, let's assume the current that I have to find is the current to the resistor, let's call it I1. That's the current through this branch. Okay, let's assume the current entering here is what? I2. Okay, now at this point we assume that this place is the node. So as the current enters this node, it splits into I1 and I2. Now the formula we are going to use is called the current divider theorem. Okay, now what does it state? Okay, to calculate I1 using the current divider theorem, okay, that's going to be the source current I total times opposite resistance R2 over R1 plus R2. Okay, this is what we call CDT, the current divider theorem. Okay, I want to see that we'll get the same answer with 1.21 amps. Okay, now let's plug in the value. So that means I1 equals what total current, that's 2, multiplied by R2 is the opposite resistance, that is 5, divided by the sum of the resistances, that's 3.3 plus 5. By the time we do this, we are going to get 2 times 5 is 10. 3.3 plus 5 will give us 8.3. That our I1 will be equal to 10 divided by 8.3. Let's see. 10 divided by 8.3. That's like 1.20. Okay, 1.20 amp. Now what do you observe? The value is very close to the initial value we got here, difference of 0.01, which shows that our current divider theorem is equally applicable. And remember, we only apply the current divider theorem to circuit arrangement where we have just what? Only 2 resistors. Okay, we can use it when we have only what? 2 resistors. Okay, in parallel. The current divider theorem CDT applies to when you have a parallel element of 2 resistors in parallel, only 2.